Yep.
Okay, thank you very much. It's a pleasure to be a part of this event and with CompassData. And CompassData is a geospatial company that has been in business 26 years. My wife and I started the company in Colorado. We're a woman-owned small business, and I'm a founder and director of the company. She is the president of the company. And Mike Gyde will be speaking today. He's a CRO for the company, and Hayden Howard, our vice president, will also be speaking. So I've been in the business 40 years. My goal is to map the world, and we've been doing that over these 40 years with work in over 100 countries, including our home state of Colorado in the U.S. I've been in the field. This picture is me standing at the tip of Africa, Cape of Good Hope, where I was doing some ground control. Family business. My wife and I and a number of people have been with us many years. We operate like a family business. And also I like to ski, play golf, and fly fish when I can. So as part of the One Compass solution, there are three companies. Compass Track is a CompassCom product that's an Esri-based GPS tracking solution used by DOTs, military, governments. It's a higher-end industrial grade solution. We're not going to talk about that today. But CompassData is the field survey mapping, underground mapping, above ground mapping, remote sensing company. And Compass Drone is a division of CompassData, which presented during the Right Away conference that was held a couple of weeks ago. So CompassData has professional surveyors and geodesists and geospatial people that are part of our team to map the world. We map from space to underground and everything in between. And we use data from our partners at Maxar Digital Globe. We use partners that have fixed wing aircraft. We have some of our own sensors that fly on fixed wing aircraft. We have a fleet of drones, mobile mapping equipment, traditional survey equipment, and we've mapped things underground from utilities to even the rock depth below the snow pack on the top of Denali to try to determine a rock elevation for Denali over the years. We are truly a technology based on GPS, GIS, wireless, and remote sensing. Many of our customers in this space are part of our heritage of building our capability, from federal government clients, state and local clients, to folks that do professional work in mapping. And we, again, have a quality management system that's based on ISO 9001, 2015. We're also certified by the FAA to do airport mapping for avionics. And we are certified on the federal and state side as a woman-owned small business, a disadvantaged business as well. So we do a lot of partnering with a lot of larger organizations. Some of them you see on the screen, where we do a portion of the project that makes sense for us, and they do a portion of the project with their capability to provide a complete team for the client. So from here on, Mike Gyde is going to talk about the technology and what we're doing to develop the GIS, and then Hayden will follow up with an example of some work we've done. So if you have any questions, please submit them with the Q&A. We're also going to have a couple questions during the presentation we appreciate your response to. And take it away, Mike.
Thanks, Brent. Yeah, this is Mike Gyde. I've been a 25-year product development guy with a specialty in aerospace. You may raise your questions why an aerospace guy's in here talking about subsurface utilities. I've been working with the CompassData product line and the remote sensing product line, both on the control surveys to generate certified aviation products historically for many years. And obviously that transition into the rest of the CompassData offerings has flowed very nicely. As we start getting into this, I pulled some articles on subsurface utility engineering, and this one was from the Department of Transportation. I'm not going to read through this, but as just a reference, when you're looking at subsurface or SU related activities, there's some common words that pop out of every article. That is the words over on the right, such as accurate, exact, unidentified, existing. And every one of these, they have great, claims of fame as to how, what you're looking for in these things, the benefits that can be received. But a lot of them are not being realized unless you have an accurate product. So the whole theme as to how I'm going to go about my aspect of the presentation is to cover many of the best practices that we've utilized to achieve what's really the benefits that are called out in a SUE. Before I get into it, I'm going to jump right in with a question for you guys. I'd like for you to kind of think real quickly to understand, when you're dealing with a subsurface mapping project, what's the biggest challenges that you are seeing out there? Is it the accuracy of the survey data? Is it you're getting data, but it never answered your original question? Or trying to understand the status of the project as you're going through it? You don't know what's happening until the very end. Or is it the integration into a geospatial system such that you can use it? So that's the first part of question one. And the second part, when you're dealing with SUE, is what is most important to you? Is it absolute accuracy, relative accuracy, both? Or just give me a general feel of what's going on with my utilities. Accuracy is not important. Okay, so this is our approach to a SUE type of activity, and we've broken it down into 5 phases. But before getting into each one of these phases, I think it's important for all stakeholders to be involved in the process and have the theme of accuracy on the back end. You got to have the end goal in sight, right? So meeting with the baseline stakeholders, understanding there may be multi-divisional needs. What tooling and tooling restrictions and computing environment are you going to be having the following tool to be a part of? And really trying to get a clear expectation of the end result in mind. And with that, you can start to set up a customized solution for every one of our customers. The key part of it is to really get the requirements captured, make sure everybody's not in the same direction, and move on. And the following item, and I do get into this a little bit later on, but data mining. There's a lot of information, whether it be documented information or perhaps tribal knowledge in certain people's actually existing employees' heads. In some cases, retired employees that could be brought to the table to help expedite the SUE development. So what I got is 5 phases. One of them is really talking about surface survey, and as mentioned by Gavin earlier, could be either aerial mapping and or mobile mapping in various types to establish that foundational level of your GIS. And once again, it's not just a pretty picture, it's going to be accurate mapping and mapping of assets. And then we'll get into all of this other information, whether it be documented information and or tribal knowledge into this phase 2 area, so that you've established this baseline entity in the GIS, as well as laying the foundation to start to drop in the surveyed utilities into as another layer into the GIS. And then obviously it's the collection of the undetectable utilities, the verification in phase 5, delivery and training. So we're breaking it up into 5 phases. I'm just going to walk through briefly each one of the phases for each one of you. For those of you that know CompassData, we're a very large control point or survey point company with over 65,000 GCPs, right? So we're very, very keen on this. We deliver different types of surveys or survey points, engineering grade, survey grade, or mapping grade. But this, again, serves as the primary foundation of our accurate product on the back end. Okay, so now we've got a baseline survey points in there. We're going to collect the surface utilities and or AOI, I'll call it. We can use aerial imagery, but I'm providing options in here because not one size fits all, okay? In some cases, you have large AOIs and everything is open, where an aerial imagery will suffice just fine. And when we're getting this aerial imagery, we're not just grabbing the imagery and dropping it into the GIS. We're going to orthorectify it and make sure that it's accurate as well. So it's giving you a good situational awareness of the area of interest. In some cases, you also have LiDAR. I have that labeled down because LiDAR can also be very valuable in some of the utility requirements. This goes back to the initial slide where I talked about understanding what the stakeholders' needs are, okay? The other option for mapping of the surface is mobile mapping. Now we've used the roadway acquisition, I'll call it that way, where we're dropping 360-degree 30 megapixel inertial-based camera on a vehicle. And one can envision driving the streets and picking up the surface utilities, fire hydrants, for example, if you're talking water. It could be any devices associated with a water utility or electrical utility, all the way up to, could be at the doorstep of a house, for example. And those assets on the mobile mapping can be captured and dropped into the geospatial as well. Now, there's some mobile mapping areas that aren't very vehicle friendly. Some of them could be within a building or in the back part of some mountains or something like that, where a backpack acquisition is also desirable. So the concept of acquiring very high resolution situational awareness data to associate where some of these utilities are can be acquired on two different ways throughout these inertial type systems. And these can be both imagery and or LiDAR, either one of them. But this provides a good situational baseline in the GIS before we even go underground. Excuse me. Once we've gathered the surface utility information, and we've got the baseline of a GIS in, we want to make sure that it's correct. And we are using that through the use of our control points, which are very accurate, and we're making sure that the imagery is correct, and we can actually prove to various, whether it be a compliance issue or anything like that. We have tooling in place. Compass AA is an example of this to verify the accuracy and quality of the product. We also have LiDAR tooling as well. But this tool basically is going to show compliance to the NSSDA, ASPRS, NMAS, and MIL standards. So the quality is kind of key to this, right? I mean, we go off and collect all this stuff, then we want to make sure that it's good. So now the whole key is to take all this grand data that we've collected, and we're going to populate the GIS. This could be surface utilities. This is also the information from speaking with other people. It could be anything to help assist in the subsurface utility survey. So real quick, we just wanted to take a peek at the answers to question 1. Receiving accurate survey data seems to be the dominant challenge. And it's kind of interesting that it is the theme for a successful SUE, and yet it's one of the greatest challenges that we're seeing. Integration into the GIS is also one, which is interesting as well. I appreciate the feedback on that. It helps us try to understand where some of the pain factors are in the industry, because we constantly try to address these type of things. I totally expected that both accuracies would have been key in question number 2 at 57%. Brant, did you have something you want to jump in with?
Yeah, I think when we talk about GIS integration as well, this data also gets integrated into the CAD side for design work as well. So it's just not into the GIS, and that's when the accuracy really becomes important.
Yep. So thank you for participating in the survey. We will have another question in a little bit, and I'll jump in. Okay, so existing information. So there is documented information. So I bring this up because what we have found is there's a lot of disparate documentation regarding, and sometimes the same utility. And they maybe, there's a best practice to figure out which one is the governing document, and it's pretty interesting discussions sometimes. But the key is to get the documented information into one consolidated GIS so that all people are looking at the same information. So there's no misinterpretation of the information. And as I mentioned, it is key to get the locals involved that have a history. Sometimes they're employed, sometimes they're not, but it's always good to get any information that you have where there are known problems or there's overlapping utilities, all of these weird things that you can almost identify before you even start to survey. Heads up, this is going to be a problem area. This is a hot spot. You may need to have a little bit more intricate surveying techniques to really define what the heck is going on, especially when you're looking into 2D or 3D type of developments of your surface. So we're taking it all, we're putting it into our platform or your platform for that matter, the VGIS, I should say, such that everybody's looking at it in the same sheet of music, whether it be the subsurface utility, the surface utility, or anybody. We want everybody to be looking at the same sheet of paper. Okay. Question 2. So how do you usually go about your subsurface utility projects? Is it pretty much done in-house? Do you outsource the whole thing to a third party, or is it a combined? We'd use our resources, we outsource it to other people, etc. This is kind of the interesting question, because it's kind of like, I could have changed this question to be two-part. How do you want it to work, or how is it currently working? But more often than not, there's definitely some cooperative efforts that are going on, and I'm really trying to understand how you guys currently operate today. And 2 is the preferred GIS tool. It's interesting that we see a lot of disparate systems that we ultimately are integrating with. But there's again, this is a twofold kind of question, and maybe that can come up in the Q&A in the end. Is we're currently using maybe an in-house tool, but we'd like to be in an Esri tool or a different CAD or something like that. But we're just kind of curious, how are you going about it today? Okay, so now we're getting into where the rubber hits the road, right? We're down into surveying the utilities itself. So more often than not, we're out there doing the subsurface surveys, as we talked about earlier, but we partner with third-party companies such as WGI for a lot of this activity, where we're going to focus on what we're really good at, and maybe a third party has special experience in another area, but we'll work together with third-party companies to create it. So we've got this surface utility map, and we'll take work with the third party so that they're out there collecting the surveys, whether it be 2D or 3D, and they're dropping the attribute information down on the pavement and or landmass to be collected. So as they're marching along doing the survey, we're going to be following them at a predefined time after we feel that they're complete. We work that out amongst the two of us, and are dropping more key geospatially correct control points or survey points to assess all of the attribution and the latitude, longitude, and vertical X, Y, and Z of that particular line. On the right, for example, is an example attribution that could be handed over to us for population from a subsurface company, survey company, or party or partner that we're using. And we'll populate that into the GIS once we've validated the appropriate survey points that are associated with the utility. So again, here's an example of how we're working with other guys sometimes, but more importantly, we let third parties engage into here if they want to really specialize on the subsurface aspects, but we're all working on the same platform. Okay, so everything's going well, right? Maybe you don't need a phase 4. Phase 3 captured all of your utilities. I can't say that has happened very often, if it's happened at all. So you got to have the alternate means to identify the survey. So one of the techniques, obviously, is ground penetrating radar. And I imagine everybody on this call or this webinar is very familiar with ground penetrating radar, but that is definitely one of the techniques that are used. And also potholing, when we have to have a very precise, especially on the 3D aspects of many of these utilities, where we need to have a very precise identification of where that particular survey line is. The potholing technique will be brought in. And again, those dimensions, volumetrics, all of those attribute information will be handed off to us to be populated into the GIS. And finally, we get to deliver, all right? So it's delivery and timing. This is an interesting slide because it gets into different things. Typically, the best path, the most successful path, since we're talking about best practices here, has been utilizing the cloud-based solution, having the GIS basically alive on both ends with our customer, with all parties that are involved with the project, such that they can see the information as it's evolving, following a collection or submittal into the geospatial database. So this is really key. We'd like to be transparent, so you'll see things. It's another way of having our automatic configuration by putting things into the cloud. It's another advantage, but we like to have transparency and open communication during the process. If there's a problem area, we want everybody to know. But again, it's a configured environment. Everybody has their hands into it and they can see it, okay? The second part to finalize the project is the training. So as part of one of the questions, people are going, understanding the GIS that you get. Well, envision if you had this tool up and operational and you saw it, you're playing with it through the duration of the project. You're seeing it evolve. So there is some on-the-job training, but we also will make sure that the deliverable meets the intention of what you're after and giving you the appropriate instruction, so that you can see what is being delivered to you. There's nothing worse than receiving a tool with a whole bunch of data in it and not having to use it. So we want to make sure that we're meeting that intention. So the whole concept of a cloud-based, assuming your environment will allow it, is very advantageous to the whole project success. So with that being said, I'd like to hand this off to Hayden Howard, who will talk about a particular, a real hands-on project. So Hayden, I'm gonna let you take it away.
Great, thanks Mike, appreciate it. So I'm Hayden Howard, I'm Vice President of CompassData, Compass Drone. Have a degree in planning GIS with a concentration on aviation and meteorology. I've been working in the geospatial survey and remote sensing profession for 15 years. And started off in the field collecting control and other survey data all around the US, in Europe, Africa, Australia, and just have lots of experience with datums and geodesy and different requirements for different projects, and been doing utility mapping for quite some years as well. So as Mike mentioned, I'm going to jump into a specific project and just get into the detail of how we planned it, how we went about it, how we communicated with the customer, how we captured the data, QC'd it, maybe some of the issues that we came to, the best practices that we learned going into this from other projects. So just going into a single project and giving you guys a view of the workflow that was involved in that specific project. So the project I'll be discussing today is a natural gas pipeline locating and mapping project, and it was in the Lake of the Ozarks area, Osage Beach in Missouri. There was 360 miles of main line that was mapped and 3,500 service lines and meters. Pipeline markers and valves, covers, any other information that we could get out there in the field that was useful to the customer, we did it, right? They had specific requirements for what they wanted and the accuracies, and we did it. And then there was other data that we told our field guys to go out and get. while they were there, including the problem areas. So what did we map? This is kind of what it looks like just in general, the meters on the houses, the markers, the valves, the main lines that connect to the different service lines that go to the houses. And then this project was pretty unique in that we ended up logging problem areas, which I'll talk about here a little bit later. So for this project and many of the natural gas pipeline projects that we've done, we have developed just a good, robust workflow to ensure accuracy and compliance. And it's a logistical challenge in some of these projects just to get around and to get accurate data. So all of that's been kind of built and kind of showed here in the workflow overview. So we start off with project preparation and looking at the correction source available in the specific area. We do accuracy checks with NGS monuments. So we review where we do have monuments within the area that we can tap into to check with our QC later. We work closely with the customer on the data dictionary side, right? So what kind of information do we want to gather while we're out in the field? Or what kind of information do you have that we can incorporate into our data collection units and then update as we are out in the field? And then what kind of equipment to use. And then the data collection itself, the locators that we used on this project were L3 or that RD 8000, where you put the tracer wire, hook it up, and you get a signal and you're walking along and you map. And then the pictures, which was something that was kind of a unique thing we did for our customer in this one, which was we took pictures of features and meters and contextual down to the serial number on the individual meters, which you'll see here in a second, and incorporate that into the deliverable. Processing for this one, it required mapping grade GPS. I think they wanted it to be sub-foot, so 30 centimeters or better. So we used mapping grade Trimble equipment and Pathfinder Office as the processing software. We did static post-processing, which I'll explain why we did that within the correction source information that I'm coming to next. Reported the accuracy and did accuracy and datum verification, which is part of our process. We QA, QC all of the data that we are processing, clean it up, make sure it meets the requirements of the customer, and then export it, in this case, into a Esri geodatabase for delivery. So that's a good workflow of how this project went. So let's jump into some of the details here. So for the initial project preparation, in Missouri, we were looking for real-time networks, and since we survey all over the country anyways, we have a good list of them, but we tapped into the Missouri DOT VRS network, and that was used. So our units had SIM cards in them and had data connectivity, and we were able to take those units out, connect to the RTK VRS network out there, and get real-time corrections, which was great, that we didn't have to post-process a lot of data, and the network worked out really good. In some cases, when we go to the field or to projects, it's not an option. Maybe you're in some part of North Dakota and real-time network isn't available, and then we have to determine what kind of equipment we use and processes we take to capture data based on the customer requirements for that project. For the Missouri, we also looked at the available Coors base stations for the post-processing, which, like I said, I'll talk about here in a second why we did that when we already had a real-time correction. Looked at monumentation, used a few different apps to identify good control points in NGS monuments for our field crews to go and survey once a day for our accuracy checks. So once we get all that figured out, we get out to the field, and we were doing two-man teams. And for this project, I think we had up to 4 two-man teams at one time to capture all this data in the time frame that we had. one locating and one mapping and leapfrogging, basically with a car and a bike per team, and we found that to be much more efficient. Basically, it's just a logistical challenge, I guess I'd say, to make sure our field guys are as efficient as they can be. And with the locators that we were using, you hook them up with the tracer wire and you walk, and at some point you run out of signal, and then you have to go back and get the box that you hooked up to get the signal and move it to the next location where you can hook it up again. So this is where we gained efficiencies by like leaving a bike somewhere, so when the locator got done, they could go back and get that, and the surveyor would be falling behind them. And by the time the surveyor got done mapping what the locator had marked, they hop in a car together and they go to the next spot and keep moving forward. Metadata was captured with pictures, serial numbers, as I mentioned, and I'll show you a visual here, which is much more powerful than me talking about it. And we used also laser rangefinders. So with the meters on the house, this was very important to the customer. It's good to have the elevations, the exact Z value for the meters so that they can ensure that there's fair billing associated with the location of this meter at a certain home there. So, and the other thing we did is we identified these issue areas, right? So we were out there and we were contracted by a natural gas company that said, hey, here's these locations that we need you to go map. And sometimes we get out there and there would be no pipe in the ground, like this picture over here, right? So outside the scope and above what we were supposed to do, we said, hey, field guys, when you're there, use your smartphone, your tablet, which we equipped them with, and an app, and we used a few different ones to capture that and write down some metadata. We created a data dictionary, like what is the problem, right? Can you not access it? Is it not there? Those kind of things, and that proved to be very valuable for our end customer. Because a lot of times they had paid their contractors who said that the pipe was in the ground for these areas, but they were just told it was done and had no verification that it was or that it wasn't. So, and then after data capture, we do upload, and this is happening nightly, right? So our field guys would upload via our FTP, Dropbox, a couple different ways to get it to us, and then our office staff would do daily check-ins and post-processing to make sure that the data that was received the day before is sufficient and works for the crew, and there are no recollects needed. So this was key to this project being successful. And the other thing we did with that data was we were giving live updates every day, so that when we had all these crews out there, they had mobile devices where they could see what's been collected already to ensure that nobody was recollecting an area. The Lake of the Ozarks location had a lot of challenges, and it gets really windy with the roads, and just making sure all team members were in areas and being efficient and not remapping something that's already been mapped was a challenge we had to overcome, and this is how we did it. So with post-processing, you get the check-in side done, you get the QC, and you get that back out, and that's rapid. And there's another round of post-processing that we did in office. So this was, before the final delivery, right? So this is taking MDOT corrected SSF files from our mapping grade units, and then taking some of those, a portion of them, and recorrecting them with Coors Bay stations. And even though the real-time correction data is there, we took the steps of taking some of these files and post-processing them, and then just comparing them to what the real-time correction was to make sure that we weren't having some anomaly happen there. The other thing we were doing, as mentioned earlier, is surveying monuments every day, right? So we survey a monument, and in the office, we check against our coordinate to the monument to ensure that the coordinate system datum and accuracies are being met. And it's a daily check that we did with all of our crews. And with the laser rangefinder, we were trying to think, okay, how do we test this? How do we know we're achieving accuracies with this? So our guys would go and hit the monument with that every day. They'd put a rock on top of the monument that they also surveyed with a traditional 2-meter range pole, and they'd shoot it, and then we would check the accuracy of that as well. Yep, so the QA/QC and formatting of the deliverables, so it's really cleaning things up, SnapIn Lines. A lot of times you got to walk past just to make sure that you connect the 2 lines from a main line to a service, and get that all cleaned up. And then we created a Python script, or found a Python script, I'm sorry, to associate the photos with all the meters and all the pictures that we took and the data that we provided to the end customer. So in the end, this is kind of what the deliverable looks like, right? You got accurate data. It met the requirements of the customer, which was sub-foot. They got problem areas, locations, and we did 360 miles of main and 3,500 meters in just over 3 months. And all this contextual pictures are associated with the point that's surveyed at the location for the meters. And with those pictures of the meters, we got down to the detail of, okay, let's see what kind of meter it is, which we put into the data dictionary, and what's the serial number. And then as you can see here, we would take multiple pictures, right? What's the contextual view of the building, right? And then where is the meter on the building? That's what this picture is down here. And then a close-up. And we would survey the point and associate all that information with the point, which was really helpful for the end client. So all in all, this was a great project. Customer was very happy, and at this point, I think we're going to move over to maybe Q&A, or if we have the answer to the second question, and we'll get Mike and Brant up here as well.
Yeah, so as we see here, it looks like it's really a combination. With a lot of it is a combination of internal resources and third party, which we would expect. Because again, getting information from people that are in the know about the infrastructure combined with what we see or collect in the field, I think is really important. A lot of folks, of course, are using CAD, and there was a question about, is BIM including in CAD? And in the perspective of design, I would say yes. If you're designing and running underground utilities into a facility, then the BIM would be important as well, in the CAD as well as the survey underground outdoors. Hope that answers that question. But CAD is a big part of it, and then we've heard out in the industry how people not only want CAD, but if they're doing environmental for DOT or other things, Esri-based combination of the CAD and the Esri or GIS data, and then maybe Bentley or Esri is used in other departments and has value. In the case of the utility that Hayden was talking about, that served for operational purposes. It also served for the ability to value the utility as far as what their resources were, because they were funded by outside, it was an outside private equity funding of this utility, and to be able to put value and accountability on what was in the field. And that was a very important part of that as well. Gavin, do you want to go through the questions that were submitted, or would you like us to? How would you like to proceed there?
Well, I got questions from a couple of different places. Some people have emailed them, which is kind of odd. But you spoke to the question from Terry about BIM being inclusive in CAD, and actually the term BIM is applied to heavy civil now, not just buildings. So there's understanding that those terms can get a little confused. But the question about is the data being gathered for the location underground utilities, is an accurate depth also recorded in this work that, for instance, you did for the gas distribution system?
Yeah,
how accurate for depth?
Yeah, really good question from Cliff. Thanks for sending that in. So with this specific customer, they needed to know a depth reading, but they wanted it at the location in which we started surveying. So it's not how we've done all these projects, but for the Missouri one, it was, we're going to use the locator, and it has the ability to tell you how deep it is. And we would get that at the beginning and record that for the entire line that we walk, and we would do it at the next one. And the accuracy of that, per the locating equipment that we had, was plus or minus 2 inches, and which was good enough for the requirements of that customer. If more accurate and continuous Z, like how deep it is under the ground, is needed, there are ways to link up the locators that we've used with the data collectors, so that every time you locate it, it's sending the Z value to the controller itself, which we've done that as well. For this one, we were doing 2-man teams, but in other cases, we might have a 1-man team that is locating and surveying at the same time, and that's the way we would approach that for those depth readings. So.
Okay, there's a question from Ryan about what type of camera you use. Standard phone cameras?
Yes, good question, Ryan. For this Missouri project, we had the geo units, and they had a camera on them. So as we would go out and build the data dictionary specific to this project, we would say, okay, when you get to a meter, here's this drop down to take a picture, and there was a camera right on the unit itself. And then for the problem areas, we had just set our guys up with tablets, and I believe it was the Samsung tablets. And that was just snapped with our tablets, and then that automatically came through a cloud and had attribution as the data dictionary as well. That got incorporated into deliverables that we gave to our customers. Again, that was above and beyond the spec, but that's how we captured that information, was tablet cameras with an app to record the information on the problem itself.
Okay, got 30 seconds for the last question. How deep does the locator you're using, how deep does it go?
For this project in Missouri, I think it was rated down to, I think, 5 or 6 feet. I'd have to go look that up and get back.
Okay, that's my understanding, is that's about the range.
Yeah.
So a lot of utilities besides like drainage and sewer are within the 6 feet typically of the surface. So
Yeah.
got to thank you, Brant, Hayden, and Mike. Mike, my apologies for mispronouncing your name. I was going to flip a coin this morning. Is it Gyde or Gyde? Sorry about that.
No, you're the first one to ever mispronounce my last name, Gary.
Oh, good. Yeah. Same with me. No one's ever mispronounced mine. Yeah.
When he comes in on caller ID for me, it says Mike Gyde. So,
Oh, God.
so it can be all of the above.
There you go. Gentlemen, thank you very much. Really like the real world examples. We're going to jump in to stay on schedule. We're going to jump in.